Hello everyone. So today we're going to go through this numerical tolerances on lists question. So this is a question that's come up a number of times from different people, and what we really want to do here is allow a bit more flexibility in how we can grade a student's response. So here we would see that a student may want to enter in the answer to this question, which is the minimum of this function, and they may enter the answer of the form 2, 5. However, there may be a range of answers that students might enter. So they might enter 2.1, 5, might enter 2.1, 5.1 or something like this. So there could be a range of answers, and we want to be very lenient on the students and what they might enter here. So how can we do this? So this is the topic of today's lesson. Okay, so where to start? So what we're going to do is go create new question text. Okay, in the question name, put anything we want. We'll call it numerical tolerances on lists demo 1. Okay, so I'm going to put some question text in here. So let's put below is a plot of a function. And I'm going to put $plot. That's just going to be a placeholder for the plot that we're going to generate in a second. From the graph. So, next thing we could do is we could put a place for the student to answer the question. So, in here we're going to put the response area. Okay, so in the answer we're going to put $TA. Right, we'll leave the grading code for now, because we'll come back to that later, after we've created the question a little bit, and that way you'll understand why we've used the grading code we have. But for now, we're going to choose Maple syntax and text entry only as the text boxes. Press OK. Okay, great. So that's the question. Now let's scroll down to the next bit, the algorithm. We're going to put some comments in so we know what we're doing. So we start comments with hash. And we're going to define our variables. Okay, we start a variable name with dollar in Maple TA, so $A equals 2, $B equals 5, that's be our two of our variables. Then we're going to do calculate graph range, and we're going to put bottom range equals $A minus 2, and top range equals $A plus 2. Okay, so what do these mean? Right, so if you want to plot a graph, the graph needs some ranges on the x value. So here, A is going to be the central point of the graph, and we're going to calculate our top range and bottom range using these two values here. That's basically what we're doing. So if in the future you want to make this algorithmic, you can add that functionality in. But for now, let's just add this, leave it like this. So, okay, for the people who don't know, algorithmic just means randomized versions. So every time you open the question, you see a different version of the question. It's good for study sessions. Okay, so remember we had our plot variable from before. So to plot things in Maple, you've got a few options, but we're going to, for this one, we're going to do use the plot Maple command. Okay, so inside here we can put Maple code that returns pictures. In this case, there's pictures of plots. So this is the sort of thing we're going to put. Now, straight away, we're going to type the last bit. So here, this is the Maple TA part. We're going to put plot options equals, and we're going to put the width equals 250, and the height equals 250. Okay, so this gives us the width and the height. All right, so that's the Maple TA side. Now, on the Maple side, what we're going to put in is this plot command. So let's just put that now. We're going to do x minus $A here. And as you can see, I've just passed this variable into Maple. And then we're going to plus $B. So that's our plot command now. Now we need to put a range on this. So we can say x equals $bottom range. That's our lowest x value. Double dots denotes a range, so that means up to $top range. No, top range. Okay, so that can be read as the plot of this function from bottom range, which in our case is 0, up to the top range, which is 4. And the plot options gives you the width. So let's press refresh on that. Which is there. Fantastic. Okay, so now for the grading code. We want to grade students based on tolerances in this question. So we'll put another section in here called answer variables. Right, so let's define a couple of variables. So we're going to use absolute error for our tolerance. And so I'll just call the variable abs error. And we're going to call the teacher's answer. We're going to put that as a list. So we're going to call that $A, $B. Now, I tend to throw things through Maple, things like lists and numbers through Maple. So we get this nicely formatted list here, which is 2, 5. Okay, so that's our answer variables and our question setup. Right, so now let's go back to the question text and set up the grading code. Now then, so we're going to replace this grading code with a different grading code. So let's get rid of this one. It's a bit more thinking space then. So eval B, whatever we put in there, we still want to have an eval B on it. Okay, so but what we're going to do here is we're going to take, look at the teacher's answer and the student's answer, compare it term by term, and see what the difference is in each of the terms. I'm going to take the absolute value of that, and hopefully, if the student gets correct, they're going to get it less than the absolute error. And we're going to check both the first term, the x-coordinate, and the y-coordinate. So the code is going to be the same for both, or essentially the same. So we do $TA, and that gives us the brackets 1 gives us the first element of the teacher's answer, which in this case is a 2. And we're going to minus it from $response. And again, response is what the student answers, so that's going to give us the first element of the student's response. And we want that to be less than $ABSERR. Okay, so that's going to check the x-coordinate. Now, we also want to check the y-coordinate. So we're going to put that again, but this time we're going to change that to a 2 and that to a 2. Okay, so you can see quite quickly that that is all we need for the grading code in there. It's just going to compare it numerically each term and check that they're both within that error. If they both are, we're going to get a grade of 1. If neither of them, if one of them is, then we're going to get a grade of 0. If both of them aren't, we're going to get a grade of 0. Okay, so let's save again. Okay, there's a quick preview to have a look at the question. So what is the minimum of that function? So let's type it in, let's have a go. So if we put in the answer here of 2, 5, first of all, we want to see, how did I do? We got the answer correct. Very good. We can also press grade and see the answer as well. Okay, good. So let's see how far we can go away. So let's put 2.1 in there, and let's put, I don't know, 4.9 in there. How did I do? Good, that's still good. Right, so let's push it a bit further. So let's try 2, 4, and let's try 5. And how did I do? Okay, that's still good. So what happens if I go above, what if I go to 2, 5 and press how did I do? Okay, so that's giving me wrong. Good, so one of them's correct, one of them's wrong, and it's marking it wrong. So just for completeness, let's check that the other one's correct. 5, let's say minus, we go 525, yeah, 5.25. And again, give me correct. Okay, so you can see how this would function. Now, if you want to, you can make this question more advanced. You can give different values for one part wrong, one part right. But for today, we're just going to leave it at the simple example we have there. So now that we've done all that, we're going to press save and close. And now you have a nice numerical tolerances on lists question. Thanks for watching. Coming soon in this series of videos, we will also be exploring how to use algorithms to decide the correct tolerances and how to use tolerances on other types of expressions.